So we can have convergent series and divergent series. So a series is convergent if its sum gets closer and closer and closer and closer to a given number as the number of terms increases. So we kind of saw that with the sequences. Remember, sequences is just a list of numbers. We kind of saw that yesterday when we looked at those numbers like 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6. That number just gets closer and closer and closer and closer to 0. So its sum is going to get closer and closer and closer to the value. A series is divergent if it just gets bigger and bigger and bigger, or smaller and smaller and smaller. So it's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It just goes on to infinity forever. Or it might be negative 5, negative 10, negative 15, negative 20, and it just goes down to negative infinity. There is the sort of rare occasion that you have a negative number where it alternates. It's like if you're multiplying by negative 2, it would be, you start off with maybe 1, then be negative 2, then positive 4, negative 8, positive 16. So it would alternate, but we won't see that a lot. That would also be divergent if it's switching back and forth from the positive to negative there. So convergent gets closer and closer and closer and closer to a number. So you may see like a question on your exam, which of the following is convergent. That should mean it gets closer and closer and closer and closer to a given number. So you can only find the sum of an infinite series if it is convergent. And there's only going to be one type of series that we've looked at that is convergent. Okay? If we have an arithmetic sequence, if we are adding a number, so we're adding 2, we're adding 7, we're adding 0.1 each time, is that going to be convergent? It's never going to be convergent, because if we're adding a number, even if you start at negative 1,000,000, if you add 0.1 a gazillion infinity times, eventually it's going to become positive infinity, right? Or if you're subtracting a number, it's going to eventually be negative infinity. So arithmetic sequences, we might want to jot this down, arithmetic, which is the ones where you add or subtract a number, they are always divergent. Okay, always divergent. Okay, geometric are sometimes divergent. If we have, like, let's say our geometric series, geometrics when we're multiplying by a number, if we are multiplying by 2, we start with 1, we multiply by 2, we have 1, 2, 4, 8, 16, 32. That's going to be divergent because the numbers just get bigger and bigger and bigger and bigger, right? But some geometric series can be convergent, okay? So the types that we've looked at, the only one that's going to be convergent is a geometric with your common ratio, well, that common ratio is between 0 and 1. So you're multiplying by a fraction that's smaller than 1. Like if you multiply something by 1/2, let's say we start with 4,000, half of that would be 2,000, half of that would be 1,000, half of that would be 500, half of that would be 250. That number gets smaller and smaller and smaller. It's going to get closer and closer and closer to 0, right? So the only type of series that we're going to look at that can be convergent is the geometric series where we're multiplying by a fraction, or it looks like you're dividing there, right? So this is the problem I was talking about yesterday that I think is very interesting. Organizers plan a race where first place wins $1,000, second place wins $500, third place wins $250, fourth place wins $125, and so on. They advertise for this race that every single participant gets a prize. How much money should they have on hand for prizes? So they're going to give every person that participates a prize following this pattern. So like if you were in 5th place, you'd get half of $125. right? And then if you were in 6th place, we don't know how many people. This is eventually going to go to 0, right? Eventually, if you were like myself and you're in like last place out of 500 people, then your prize is going to be pretty much 0. Let's assume that it is possible for us to give people a fraction of a cent, right? Because that's not actually possible, and you might as well just get 0 if they give you 0.02 of a penny, right? But let's assume, for the purpose of this problem, that it's possible for them to transfer a fraction of a cent to your bank account for you there. So we don't know how many people are. The number of people that run this race is unlimited, right? It could be 10 people, it could be 1,000 people, it could be 1,000,000 people. So how much money do they need to have to make sure that even if 1,000,000 people show up, they have enough money to give out prizes to every single person? The answer to this seems like it should be infinity, right? It seems like it should be they have to have infinite money if infinite people can participate. But it's not, which is what I think is really cool about this problem. So let's just use our calculator for a little bit. So we know the first 4 places. We've got 1,000. We've got 500, 250. We've got 125. Okay, so just for the first 4 places, you got to have $1,875. You can bet you're probably going to have enough people show up to have to pass those out, right? Somebody divide 125 by 2 for me. 62.5. So I'm going to add that amount. Okay? Somebody divide 62.5. 31.25. Okay? What would the next place get? 15 point, is it 625? Give me the whole decimal, because if we start rounding, we'll mess up. If we do 31.25 divided by 2, is it 625? You can't round for this, because if you start rounding, then it will possibly be infinite, right? But if we don't round, and we assume we can give somebody $15 and 62 cents plus that extra half a penny, then this will work. So that gives us this much, right? What's the next place going to get? 7.8125. Okay, so we're at 1992.1875. What's the next place get? And we'll quit now because our decimals are going to start getting really bad. Oh, wait. Plus 92.1875. Okay. You're getting to the point where you're not too excited about your winnings here, right? If you only won your $3.90. But the next person, they're only going to get almost $2. The next person's only going to get a little less than $1. Eventually, if you place in really low, you're going to be getting less than a cent. But this number right here, it started off shooting up really fast, but it's looking like it's sort of rounding out at $2,000, right? And if we kept on going for a while, then we would see this is going to round out at $2,000. So if the organizers here had $2,000, it wouldn't matter if the whole world showed up to run their race. They could give everybody a prize out of their $200, assuming that they could give people a portion of a cent, right? And Jonathan, he might be good to win some money at this. I might as well stay home because I'm going to be getting less than a cent, probably, maybe less than a fraction of a cent there. But so I think this is really interesting because it seems like the answer to this question should be that you should have to have infinite money, but really $2,000 will cover it because this is a series that converges, right? The prize money gets closer and closer and closer to 0, so So that means that the sum of, if we add all those together, it's going to get closer and closer and closer to a given value, which is 2,000 for this. So this formula is the one that you're going to use. There's one formula up here that we haven't used yet. It's the last one under geometric sequences and series. And notice it says absolute value of r is less than 1. That means we've got to have a fraction there. So we're going to use the formula, and it's really one of the easier formulas you got. S equals a sub 1 over 1 minus r. Okay, this is the formula you use. So our sum here would be our original amount, or our first place prize was $1,000. What is our common ratio? What are we multiplying by each time? What? 0.5. So we'd have 1 minus 0.5. So we just get 1,000 over 0.5, and that is going to give us 2,000. So if we have an arithmetic sequence or a sequence that does not converge, then we can't find the sum because it's just going to get bigger and bigger and bigger. It's just going to be infinity. But if we have one where our prize money or our amount is getting closer and closer and closer to 0, or closer and closer and closer to a number, then we can use this formula and we can find out what that adds up to. Okay? Questions on that? All right, let's do one more with this, and then we're going to move on to our log quiz. So this came from your textbook. I think it's a really interesting situation, although it is probably a little outdated for you guys since this is 1999, probably before most of you were born, right? But in 1999, Jeb Bush was governor of Florida, and he proposed a tax cut that would allow the average family to keep an extra $96. The economy is terribly difficult to predict, as you can tell by the fact that there are super smart people that all disagree on what is going to happen with the economy. But the marginal propensity to consume, which they call MPC, is defined as the percent of a dollar consumption is going to increase whenever income rises by $1. So more or less, if you make more money, it's the percent you're going to spend, right? Because let's say that I give you, let's just round it up to $100. You might, if you were my son, go out and blow every cent of that $100. Like you're feeding your extra quarters into the claw machine at Walmart. There will be nothing left. That would make your MPC 100%. You're spending every dime that's given to you. If you're wise with your money, your MPC should not be 100%, right? So what they figured is they did some studies, and they figured at this time that the MPC was 75%. So if they gave this amount to people, those people would spend 75% of it. They would save back 25% of it. And then you've got to think about how money works. If you put money into the economy, and you spend 75% of it, then that person that gets your money spends 75% of that, and then 75% of that, and 75% of that. So when you give somebody money, then the idea, that's why they do stimulus plans sometimes. I know I can remember maybe when George Bush was president, like everybody just got a check for like $400 or something like that. And it was a stimulus plan because they were hoping you would spend a good part of your $400, and that would go to businesses, and they could spend part of that $400, and then it would just sort of jumpstart the economy a little bit. I don't know how well it worked, but I did get happy with my $400 there. But here, what we're wanting to know is just that one family that gets their $96. Let's assume they spend 75% of it. And then whatever they spend it on, that person spends 75% of that. And then 75% and 75%, so on and so forth until until infinity, right? So we want to know what the total amount of money spent in the economy would be as a result of just that one family's tax savings. So this is infinite, right? Like the family, we'll call them 0, they get $96. And then, which you don't have to do this, I just want you to kind of understand what is happening here. They're only spending 75%, so 96 times 0.75 is $72. So they take $72 to the store and buy something with it. Well, then that store, they might save back part of it, so 72 times 0.75, they're going to spend $54 on maybe giving an employee a raise or, more inventory or something. Then let's say they give an employee a $54 raise. That employee spends 75% of their $54. So now they spend $40.50, right? They go to a store and buy something. Well, then the next person, whoever gets that money, is going to spend 75% of that. So we've got 30.375. So the amount of money each time is diminishing, right? You don't have as much. But money is being spent over and over and over and over. So if we did this until infinity, which essentially is what money really does because it just circulates around, it just keeps on, being passed from person to person to person to person, then eventually we could figure out how much money was spent out of that initial $96 that was given to these people. So we would do that with that formula, S equals A sub 1 over 1 minus R. So S equals, our initial amount was $96. What is our R? It's 0.75. So that would be 96 over 0.25, which 96 over 0.25 gives us $384. So whenever you hear on the news that Donald Trump is claiming that his tax cuts can pay for themselves because we're just going to be so great and winning so much once Donald Trump does his tax plans, this is the idea, is that by giving people more money, they spend that money. And when they spend that money, those people spend that money, and it puts more money into the economy. Now, the economy is incredibly complex, and I do not know nearly enough to tell you whether or not I think that's actually going to work or not, because there's all kinds of things. Some people might save their money. Some people, the government's definitely making less money because they're having less taxes, so did they cut them too much? Not enough, who knows, but yes. It's just the system of trade. Long ago, you might just trade a goat for, 5 chickens or something. It is just a system of trade where we don't have to find somebody that wants our goat because we've just got money, So that's it. We could go back to just trading stuff, like I would, instead of them paying me to teach you math, if your parents want you to learn math, they would maybe send you to school with a dozen eggs or some milk or, something like that, and I would live off of whatever the kids brought me, we could do that, but it's more simple to have money, because then you can trade it for whatever you want, so, although it can become very complex and big. I am.